Our next talk and final talk for the session is from Jacob van Etten. Jacob is a principal scientist at the Alliance of Biodiversity International and CIAT, one of the CGIAR institutes, which is one of the headquarters is where we are at the moment. He is a research director for digital inclusion and directs a research team that works on digital design in agriculture and resource management. Jacob has a PhD from Wageningen in production ecology and social sciences.
Thanks to all the organizers for the opportunity to present. So I'm going to present about on-farm experimentation in smallholder agriculture in the global south, so to say, and focusing especially on the kind of the human aspects of redesigning a methodology for on-farm experimentation. Just to put you a little bit in context of what is the problem that we try to solve with this new approach. I have this picture that I got in an old box almost 15 years ago now, where I was involved in a participatory variety selection trial in West Africa. And this was one of the moments that I realized something was going wrong, basically. So we have a very actually capable farmer here, who's also the schoolmaster in the village, leading a trial together with the National Research Institute. So a really non-average farmer, so to say, doing a trial that was designed by researchers, but also adapted to farmer conditions to such an extent that it was actually didn't have any statistical power anymore. So measuring only 3 plants per plot, all sorts of concessions, so to say, to adapt to farmer conditions, the trial, but that also made it scientifically very difficult to do something with the data. And then the other thing is that also for the farmers themselves in the workshop that we had, this was not very useful at all. So the farmers kind of reading out all the numbers one by one, and then there was very little discussion, and it was the end of the session. And that to me was a moment where I thought that this model was really broken. We need something else. And of course, I'm not the only one who is saying this. This is an article that was written in 2013 by Michael Masiko, based on experiences with a similar trial on soybean in Kenya. And he also observed like several issues with participatory variety selection. So one is observation. Farmers they had these common plots, and farmers would only come maybe 1 or 2 times to the plot, most of the farmers, and then they would all vote, and the kind of the average vote would have very little information in it, because most of the farmers had only seen the crop maybe once or twice. A lot of these fields were actually neglected, a lot of weeds. Farmers were not so interested in maintaining them. Then researchers had to get extra labor. So there's a motivation problem there as well. And then the other thing is kind of this external validity. Then when farmers got these seeds, many of them were not really adopted after a season, or maybe they were kept for 2 seasons but then discarded. Why? Because the trial conditions did not really match, and the observations that were taken on the trials did not really match farmers' reality. So that's something that we call external validity of a trial that is lacking there. So how do we get to a solution for this particular problem on farm trials under smallholder circumstances? So what is interesting is to go back to the old classic. So this is a book from '97. So Mercalli basically say we find nothing to suggest that more formal research methods will have any positive or fundamental impact on farmers' experiments. But that's quite interesting, basically saying that farmers, although they use their own kind of shortcuts and heuristics to interpret experiments, researchers can do very little to actually improve them. And they're pretty sound, actually, in a way. So that suggests that maybe we should take these experiments as our kind of departure point in the design of a new approach. What they also say is that the need is not so much to improve the methods that farmers use to experiment, but rather to increase the supply of what they call raw materials, such as new varieties, ideas, etc. Farmers can then use in their experimental activities. But it sounds very much like a hands-off approach. But they also say that it is very useful to kind of gain feedback from these trials. But they do say that we should not try to turn farmers into researchers or to turn researchers into farmers, but to create a system in which each can play their own role. So that led to a certain design approach that we kind of followed. So one of them, one of the thoughts behind it was to look for experimental design that is very close to how farmers conduct their own experiments. I'm not trying to drastically improve it. And also look at the feedback collection in a way that's really feasible under farmer conditions, make it very simple and also robust. So things that are very difficult to break down, so to say, in fairly adverse and difficult situations. And then the other thing was that we took a lot of inspiration from citizen science as a field where you can learn a lot. And I think it's always useful to look at other disciplines, how they solve problems, and take inspiration from that. And citizen science, especially in ecology, is very interesting. So what they have emphasized is to really work with citizen science, as they call them, who are self-motivated. So bird watching is a very good example. People do bird watching already. They're very motivated to do that. So you can enhance that motivation by giving them more tools to do that in an even better way, like little checklists in an app, and to really invest in a very good user experience of these digital tools. And also to design certain kind of micro tasks that are really easy to do, and that you can then, if you take them all together, you can really get a much bigger job done, basically. It makes it scalable as well. That, of course, requires that you have certain types of statistics that are adapted to that kind of data that you can collect. So, for example, bird watchers watch much more birds on Saturdays and Sundays than on Mondays and Tuesdays. So you need to adapt your statistics to that. But the value of those data is much bigger than whatever data you could collect as a professional scientist, because well, you're expensive. So, for example, what you see in the picture is when you then aggregate all these results, you can get insights into trends that have a kind of a spatial and a temporal scope that you would never have without these kinds of observations. So it's totally worth it to actually invest in working with these data, even though they're not optimal from a scientific point of view. You would like to have them sampling as much on Mondays and Tuesdays as on Saturdays and Sundays, but we live with what is in the data. So that kind of philosophy also applies to on-farm experimentation. So what did we design? We designed both an approach and a piece of software, a digital platform, to facilitate these kinds of trials. The approach is called tricot, and I'll explain later what it means. The software is called ClimUp, because the focus was mainly on climate adaptation at the beginning. So this is how the kind of the overall scheme looks like, of the tricot approach. And the core of it is a very simple experimental design, where farmers basically, they each have a plot with only 3 varieties or other technology options. It could be, we've used it also for fertilizer trials and other types of trials. And also, as core of the approach is that farmers then rank the options. So that's the basic data collection method, is ranking. We can do measurements as well, and we can train farmers to do measurements. But rankings work for a lot of the traits that we look at, or other variables that we look at in these trials. And we've kind of adapted our statistics to work with that. And just 3 options allows us to keep it, to also include farmers at very small farms, and also to keep it simple from kind of a cognitive point of view. So if you have 3 options, it's easy to remember, it's easy to talk about it. You can say which is the best and which is the worst, for example, or the tallest, the lowest, whatever. And with these 2 questions, you can easily communicate what is going on these plots. If it's more options, 4 or 5, it becomes much more complicated. So tricot, it comes from triadic comparisons of the technology options. So we've really kind of made this the trademark of the approach, that you use 3 options at the center of it. After a lot of trial and errors, we really settled on this part of the approach being central, and we came up with this name. So it all starts with the design on the platform, and that really streamlines the whole process. So it's not that you come in after you have the data and you need to do a lot of cleaning of the data, etc. So in that sense, the digital kind of streamlining of the approach is very important and takes away a lot of extra work. We generate these randomized designs, incomplete block design called. So a lot of the approaches, are actually all of the elements of the approach, are things that have been used already in agronomy and in on-farm testing. Just combined many of these of different types of approaches. Ranking has been used. Incomplete block designs are not new, of course. And the computer does that for you. The platform does that for you. It generates QR codes for all of the packages, so you can easily trace what is going on in the field. When you give it out to farmers, so each farmer receives a package with 3 options. It can be seeds of different fertilizers, can be different seed varieties, sorry. And so they each get a different combination. And that all comes back, it's collected back and then analyzed with just a new kind of statistics that can be applied to ranking data. So farmer motivation is really central in these systems, and we've done quite a bit of research on that, what motivates farmers to participate. And one of the simplest questions to ask farmers is, what do you expect when you participate in a trial like this? And it's quite interesting that farmers don't expect things like money or even the research results. It's what they really valued was the seeds themselves, and also contact with technical experts to talk about their plots, agronomic advice, capacity building, these kinds of things. So that's really important to keep farm motivation. So there is this kind of human element that we need to keep in the system as well in that sense. And then the other element is to adapt the statistics to what farmers can observe easily. So the ranking, rather than trying to force kind of analysis of variance on farmers and then getting into all sorts of trouble. So we've done quite a bit of an investment in developing the actual statistical models that can be used to analyze these kinds of data sets. And it's quite amazing what you can do with them. So you have these ranking data that you see on the left, and you can develop all sorts of statistics based on this, confidence intervals, your p-values, everything you like, and also start playing with covariates and doing all sorts of fairly sophisticated analysis. So we've built quite a few tools around this. So there's working with weather data, working with soil data, also even genomic data. We've done that as well, so working with the breeders. And that then can give you quite good insights into local adaptation of varieties, for example, as you see in the picture. So we link through the GPS points and the planting dates, we link with all sorts of databases of soils and climate, and that can give us fairly like new insights into climate adaptation of varieties. So that was it. Thank you very much.